This video was supported by Bambulab. This is the continuation of the desk setup video series. So in this video we're designing a new panel which will allow us to control the power to the camera and the key lights, and also I bought this like USB hub with switches on it, which really helps with troubleshooting stuff. So if my Looptech CT or my mouse or something like crashes and it kind of fails, what I'd previously have to do is lift up one of the panels and then unplug the USB cable and plug it back in, which takes like, it's not that big of a deal, but sometimes you can't find a cable and that kind of stuff and it takes a while. So another thing I'd really like to change is the angle of the camera itself, because at the moment it's at such an angle that when I'm sitting behind a desk setup, for example, to do a tutorial video, the frame kind of ends right in front of my face. It just doesn't look good. The way I went about this is putting the teleprompter in the correct position, then taking a picture of it, and then inputting that picture into the CAD software so we have the correct angle that we need to adjust the 3D printed component. And that 3D printed component goes between the speaker mount and the VESA mount, and that is attached to the monitor arm. So that, you know, later on we're also going to be 3D printing a little component that goes between the speaker and the teleprompter, and that will unify that whole situation over there. The printer that we're using for this project is the Bambulab A1. They actually sent this over for this video, which is pretty cool. So they sent it over with the AMS unit. It allows you to attach multiple different spools of filament in different colors, and then print in multicolored, like, you know, do a multicolored print, which I'm not using here, but I am using it to be quite lazy. So when I have a prototype, for example, I send it over to the printer to be printed in blue, and then when the final version is ready, then I print it in black. And it's just really easy to quickly swap between those. It has a build volume of 256 millimeters squared, which is quite a lot larger than I'm used to, and it really helps with this project because later on we're also like 3D printing some larger components. The design of it is also just really beautiful. Like, I think this is going to be the dedicated time-lapse printer because it looks so good. I mean, the quality is also just way better than my other printer, so, you know, it's a win-win scenario. You get beautiful time lapses of the things that we're building here, and I get great quality prints, which I was really surprised by that. Took it off the build plate, and this was with the time-lapse tool enabled. Usually there's a ton of stringing, and that doesn't seem to be the case here because it has like a nozzle cleaner at the side. So when it stores its print head, then it kind of scrapes over the nozzle and it gets rid of any excess filament that might have come out during that travel process. And there might be some Black Friday deals going on, which is pretty cool. So after this we could start designing the panel that holds like the tumbler switches alongside the USB hub and also the control panel for the FlexiBot sit-stand legs. Prior to this I would have quite a lot of trouble designing these parts because it's a very test intensive kind of process where there's a lot of trial and error going on. But I actually bought myself a 3D scanner, which was really expensive, and I don't, you know, it's not necessary to create these panels. You can just use a caliper and a angle finder and that kind of stuff like I used to do. But this was really like an investment into my time. So I built like this 3D scanning station with like these little pokes for the infrared scanning, I believe it is, or the laser scanning. With this model specifically, it would be very difficult to find the angle of the FlexiSpot control panel, and in relation to like where that screen is and where you'd have to make the gap to make that screen visible, right? And with this one, it's already there, like all the information is there, so you can immediately model out where the gaps are going to be to mount it, and then also, you know, the front gap where that's going to be. There might be some kind of trial and error process in that regard, but it will be a lot less. In terms of the switches as well, they come with these little caps, but I'm absolutely certain that if I do this in the old method, I test print it and then figure out that the caps are too close to each other, for example. So those 3D scans of those switches came in very useful, where I could actually see like, okay, what is this going to look like in relation to the other control panel on there, you know? Does it feel okay and that kind of stuff? So after that, I sent it off to the A1, and I'm really happy again with like the time-lapse quality that this thing provides. It actually just has the time-lapse tool built into the software. But I pulled that off the build plate and immediately like the support structure just removed as well, which was really nice. I've always had trouble with that. Yeah, the print quality on this machine is just absolutely bonkers. The entire design, which is really beautiful on this printer, is just like it has a character, and I wouldn't be surprised if sometime in the future we'd be adding like large language models into devices like this so that you can actually ask it questions like, you know, where is this setting at? And then it would actually answer you. The FlexiSpot control panel, I did have to use like a little bit of duct tape to like add 0.5 millimeter because it was 0.5 millimeter off, and you could see like the edge of the control panel. But other than that, all of the other measurements were completely correct. So the angle was exactly what it was supposed to be. The placement of the holes where we would mount it onto was entirely correct. I'm just really excited about this 3D scanning tech. Like, I can imagine a lot of projects coming up will be using this thing. This entire process, I don't want anybody to take this as a tutorial in any way. Like, I studied electrical engineering, but that was a very long time ago, and I pretty much forgot everything that I've learned there. The things that I'm doing in this video, they might just be like a massive fire hazard or something like that. It's quite funny actually, in the previous video we made like that EDC multi-tool, and in this one I'm mostly using like the Swiss Army knife again. So the Swiss Army knife is actually like perfect for electrical kind of stuff. So it has like a crosshead screwdriver on there. You just unscrew the plugs. You can use the knife to take off the shells of the wires and then take off the internal shells of the wires as well. You have to be careful in this process, but when you've been doing this for like a long time, it almost becomes like second nature. It's really relaxing to do. So I was also really curious as to what's actually inside of these switches. Like, how do they actually work? Are they like safe? And I was mainly taking this one apart to check out its reliability, because I have had some of these switches fail on me before, and just wondering like what actually happens when that goes on. Why does it fail? And to my surprise, the design, I'm not too chuffed with the design, to be honest. So it has like a conductive seesaw in the middle, and when you flick the switch, there's this plastic component which goes over it and flicks it to the other side, so that it actually makes contact, and that's when it goes on. And then you flick it to the other side and it goes off. But that plastic component doesn't seem very durable to me. That seems like something that's going to fail like really quickly. The plan actually was to keep everything like properly cable organized within the cable management system of the desk, but it just becomes like a bucket. Anything you want to put in there, you just press it in like I'm doing right now. Now the hub that's in this thing with the buttons on it actually has its own power supply, and it didn't really fit, like the cable extended too far. So I had to take a knife to that and then cut off some of the excess. We don't really need this because there's not going to be a lot of strain on this cable when it's inside of the desk setup. Eventually it just fit perfectly, and it held the panel in place as well, which is really nice. The last thing I really wanted to do was make like a unifying piece to go between the teleprompter and the speaker, so that they're connected with each other, because when you're rolling this thing around as well, everything's kind of shaking, and when it's shaking with each other, it's not that bad, but when it's shaking against each other, it makes a jarring sound. But also, I thought it would look a little bit better, so I took it to the 3D scanning station, scanned the speaker, scanned the Elgato prompter. Again, this is like a really relaxing process. It's really fun to watch it appear. In the CAD, basically made like a mold which also utilizes the screw holes that are already on the speaker, because we now have really accurate measurements of everything. We don't need to drill new holes into that speaker. We can just reuse those. That's a really big benefit of using this scanner. And for some reason, I printed this in gold, which was a really big mistake. Yeah, I'm probably going to reprint this in black because it looks like Pablo Escobar's setup or something. And the camera I have behind the teleprompter is the XT30, so I'm attaching that one with like a dummy battery, which allows us to flick the power switch and then the camera immediately goes on, because it's already turned on the camera side. The only thing it needs is to receive power. It's a decent camera, but in the summer when it's a little bit hotter, it overheats when I'm using it for this scenario. So that's an issue, and I might actually want to, switch over to a full frame camera someday. So the way the camera actually works and the way I've recorded these videos now, flick this way to the camera goes on, and I'm recording directly onto the computer. So that when I'm finished with this talking head video, it's immediately there. Just immediately import it into the editing software. And you could do live streams with this as well, if you wanted to. And the teleprompter actually goes into the USB hub with the buttons on there as well. So I could just turn that off when I'm not using it. So I hope it gave you some inspiration for your own stuff, and I hope you'll stick around for the next episode in the series. We're integrating a KVM switch, which AV Access has sent over. There's also going to be an entire dedicated video as to how I use it, with a lot of really useful tips and stuff that you might be able to implement into your own stuff. Hopefully see you in the next one.